tonight with what the GMAT characterizes as a hard, what they call data sufficiency question. I think it's kind of overkill to call it that personally, but if you take a look at this, you would say, well, sure, x cubed is always greater than x squared. For example, if x were 4, x cubed would be 4 times 4 times 4, which is 64, which is greater than 4 times 4, which is 16. However, there are exceptions, and this problem turns out to be one of those exceptions. Now, let me, right here, the way this is worded to me is slightly ambiguous. You have two, what they call refer to as statements. Statement 1 says that x is greater than 0, and statement 2 says x is less than 1. So that's really an implied and condition. And so what you can say right here is that these two statements combine to give you kind of a more simple look at it. 0 is less than x is less than 1. Okay. And to me, it's more, you're better off writing it this way. This is what I think they refer to as a compound inequality, or you have x trapped between 1 from above, 1's an upper bound for x, and it's strictly greater than 0. So it's strictly greater than 0 and it's strictly less than 1. Okay. Now let's just work with a concrete example. Notice that let's just pick a number in here. A simple number that would be like this would be 1/2, right? So we certainly know that 0 is less than 1/2 is less than 1. Right? No doubt about that. But look what happens when if we take this value of x, a concrete value of x, and substitute it back here, we would get that 1/2, and I'm writing it over here, I hope this doesn't cause a distraction. That would be the same thing as saying 1/2 cubed is greater. And again, y'all, I'm substituting this directly because this is a question, right? It says, is x cubed greater than x squared? Without these conditions, you would normally say yes. They're just a resounding yes, right? But right here, they're telling you that the x of choice, the domain, if you will, the restricted domain, is a value that's strictly greater than 0 and strictly less than 1. So this would, picking a number, a representative number, we picked 1/2, and so we're substituting it in, and we end up with this statement right here. Okay. Now, of course, that's the same thing as saying 1/8 is greater than 1/4, right? And of course, that's obviously false. And so the answer to this, just based on this information right here, and you can envision the same thing would happen with any number between 0 and 1. It could be 3/4, and you're still going to get a number that is that results in a contradiction. So the answer to the question would be no conclusively. Okay, no, all right? And conclusively, no matter what, if you pick a number in this interval, the answer is no conclusively. Now, again, that they may not accept that as a proof. This to me is pretty convincing. Another way to look at it is algebraically, like I've done right down here. So we're rewriting x cubed greater than x squared like this, or as I just subtract x squared from both sides. And so when you subtract x squared from both sides and you factor out an x squared, you get this statement right here, okay? Now, this part right here is certainly always positive, right? Something squared, squareds cancel the sign. So that piece right there, x squared, is definitely positive without any further consideration. But notice right here, x minus 1 itself can be written as x minus 1 is less than 0. See, and this is what I think is pretty straightforward. This is the algebraic way of proving it without doing any numerical computations. So in other words, statement 2 alone tells us that x minus 1 is less than 0. See, I just subtracted 1 from both sides and got this statement right here, which is absolutely equivalent to statement 2. But that would mean that this piece right here, this entire parenthetical piece, is always negative, right? And so you have a positive multiplied against a negative, all right? And another way of stating that is that means less than 0, right? But this says greater than 0. So again, algebraically, the answer is unconditionally no, okay? All righty, folks, I hope you like that. Let me know if you have any questions.